Researchers at North Carolina State University have developed a robotic gripping device that is gentle enough to pick up a drop of water, strong enough to pick up a 6.4 kilogram weight, dexterous enough to fold a cloth, and precise enough to pick up microfilms that are 20 times thinner than a human hair. In addition to possible manufacturing applications, the researchers also integrated the device with technology that allows the gripper to be controlled by the electrical signals produced by muscles in the forearm, demonstrating its potential for use with robotic prosthetics. The researcher says that it is difficult to develop a single soft gripper that is capable of handling ultra soft, ultra thin, and heavy objects due to trade-offs between strength, precision, and gentleness, and says that their design achieves an excellent balance of these characteristics. The design for the new grippers builds on an earlier generation of flexible robotic grippers that drew on the art of origami, which involves both cutting and folding two-dimensional sheets of material to form three-dimensional shapes. The new design is able to achieve high degrees of strength and gentleness because of how it distributes force throughout the structure of the gripper. The strength of robotic grippers is generally measured in payload to weight ratio. These grippers weigh 0.4 grams and can lift up to 6.4 kilograms. That is a payload to weight ratio of about 16,000. That is 2.5 times higher than the previous record for payload to weight ratio, which was 6,400. Combined with its characteristics of gentleness and precision, the strength of the grippers suggests a wide variety of applications. Another benefit of the new technology is that its attractive characteristics are driven primarily by its structural design rather than the materials used to fabricate the grippers. The researchers have demonstrated that the grippers can be used to handle sharp medical waste such as needles. The researchers also integrated the gripping device with a myoelectric prosthetic hand, meaning the prosthesis is controlled using muscle activity. In proof of concept testing, the researchers demonstrated that the origami grippers could be used in conjunction with the myoelectric prosthesis to turn the pages of a book and pluck grapes of a wine. The gripper design has potential applications in fields ranging from robotic prosthetics and food processing to pharmaceutical and electronics manufacturing.